Good day, everyone. This is my ABW508 Analytics Lab presentation. My name is Li Jiachen, and today I will be presenting my project. My project title is Predicting Bank Consumer Attrition Using Machine Learning, a comparative analysis of 6 classification models. Let's begin with a quick overview. Customer attrition is a major concern in the banking industry. It can directly affect profitability and growth. This project aims to predict the customer churn with the 6 machine learning models. I use a dataset from Kaggle with 10,000 bank customers from France, Germany, and Spain. This model includes logistic regression, decision tree, ranked forests, k nearest neighbors, support vector machine, and charge boost. Among these, charge boost gives the best performance. I also use Shep's value to explain which features were most important in the predictions. This project provides insights that can help banks reduce churn through early interventions. Customer churn is a growing problem in retail banking. Banks face strong competition, and keeping loyal customers is getting harder. It costs more to get new customers than to keep the exciting ones. Also, churn is rising, especially through digital channels. Even though this problem is serious, many banks still use rule-based or backward-looking analytics. They don't have tools to predict the churn before it happens, so using machine learning to predict churn can help banks take early action and keep valuable customers. This project had 4 main objectives. First, to identify key factors related to customer churn. Second, to build a compare 6 machine learning models for churn prediction. Third, to use SHAP to explain how the models make predictions. And fourth, to provide useful recommendations for reducing churn and so on. I also developed 4 research questions. What factor influence change in this dataset? Which model performs best in prediction? How can we explain the prediction using shape? And what can banks do to reduce change using these insights? I use a public dataset from Kaggle. It includes 10,000 customers from a European bank. Each customer has 14 features like age, balance, credit score, gender, and geography. The target variable is called excited. It tells us whether a customer has churn or not. For processing, I first check and clean the data. There were no missing values or duplicates. Then I encode the category feature using label encoding and one-hot encoding. I scan the numerical feature using standard scatter. First, I split the data into train and test sets. 18% for train and 20% for testing, because only around 20% of the customer churn. I used a stratified split to keep the class balance. I applied 6 machine learning models: logistic regression, decision tree, random forest, k nearest neighbors, support vector machine, and charge boost. These models cover both simple and advanced techniques. The modeling workflow follows several steps. First, I use the processed data to train all 6 models. Then I evaluate them using metrics like accuracy, AUC, F1 score, and recall. After comparing the result, I select the best model. Finally, I use Sharp to interrupt the prediction and understand which feature were most important. Here, I compared the performance of all six models using 4K metrics: accuracy, precision, recall, and F1 score. As shown in the chart, Charge Boost gave the best performance across all metrics. One list F1 score reached 17.8%, which means it balanced precision and recall very well. Random forest and logistic regression also performed strongly. In contrast, KNN and the decision tree had the lower scores, especially for recall. This tells us that ensemble models like books and random forest are more reliable for trend prediction. This page shows the ROC curves of six models. The ROC curves helps us understand how well a model can separate trends from non-trends. The closer the curve is to the top left corner, the better the model is. As you can see, chargeables again performed the best, with the highest AUC of 0.908. Random forest also show a strong curve with AUC of 0.901. Logistic regression is not far behind, but the curves for KN and decision tree are lower, which means weaker performance. The results support our inner finding. Ensemble model perform best for this task. ChargeBoost gave us the best result, but it's a black box model. So I use Sharp as to apply additive explanation to make the prediction explainable. Just show how each feature affects the model's output. Here are the top features that influence trend. Age: older customers are more likely to leave. Balance: higher balance are linked with higher churn risk. Geography: customers from Germany tend to churn more. Active: inactive members more likely to leave. Credit score: lower score increase churn risk. This result match real-world logic and give us better trust in the model. Based on these insights, I developed some recommendations for banks. First, they should target high-risk groups, such as senior customers or those with a large balance, with special offer personal service. Second, they should track customer activity. If a user becomes inactive, that's a red flag and the bank can act early. Third, they need different retention strategy in different regions, especially in German where churn is higher. Finally, bank can embed the trend prediction into the CRM system to get real-time alters and take action before customer leaves. To conclude, this project shows that Charge Boost is the most effective model for predicting customer churn. It achieves a higher score in accuracy F1 and AUC. By using Sharp, we also improved the explainability of the model, helping us to understand which features really matter. Key trend drivers include age balance, activity status, and geography. This result can help banks create a better retention strategy. There are some limitations to this study. First, the dataset is from a single bank and only reflects one point in time. Second, we didn't include behavioral or external data like customer satisfaction or app usage. Also, we didn't calculate the actual business cost or benefit of using the models. In the future, research can use real-time or time series data to improve prediction. They can also add customer feedback or sentiment analysis to the model. Finally, using cost-sensitive learning or upfield modeling could help measure business value more directly. That brings me to the end of my presentation. Thank you for your time and watching. I'm happy to take any question or feedback. Once again, my name is Li Jiachen. Thank you very much.